Okay, welcome to day 7. We're halfway through the sort of 2-week program, and it's been quite an exciting day today for us here, sort of more central Auckland with no power until recently, and then some people still don't have any power, so I feel like I should make a question based on that somehow, so we'll see. If I have time, I'm going to make up a question about power. Anyway, for this one here, I'm actually only going to do part 2 of question 7 because that's the one that's come through. Part 1 does look pretty straightforward, and I'm pretty happy that you guys are finding those sort of more straightforward ones okay. And we're looking at these harder ones like part 2. Cool, so we've got an equation of a curve, which looks kind of nice. It looks like a quadratic, that's nice. Y equals x squared minus 4x plus 4. And this line, which we don't know what the value of m is. But we know that m is not 0. So I'm going to write this just note for myself that m cannot equal 0. And we're supposed to find the value of m so that this line is a tangent to the curve, and we're also supposed to find the coordinates of that point when the tangent touches the curve. What I'm going to do actually, just so I can visualize this, is I'm going to do a sketch really quickly of this curve. It doesn't ask you to do this in the question, but I like to draw diagrams, I like to draw pictures. It always helps to make sense of the questions. So if I quickly complete the square on this one here, I'm going to get y equals x minus 2 all squared, and I'll take 4 away, and then of course there was already 4 there to begin with. So that means when I complete the square for that, it is just x minus 2 all squared. The reason I've done that is just so I want to see this on the coordinate plane there. So if it's x minus 2 squared, that means it sits on the axis at 2 there. And if we use our basic rules of plotting this, or even if we just use the y-intercept, so when x is 0, y is going to be 4 up here, I can just really quickly sketch that curve for myself, like that. And so we're after this tangent line, which is y equals mx, and there's no y-intercept, so that means it has to start at 0, and it can't have a gradient of 0. So what they're saying is it can't be that line there as the tangent. That would be too easy. It's got to be another line that starts at 0, but as a tangent. So if you think about it, it's not going to be something with a positive gradient that way. It's going to have to be something with a negative gradient that cuts this parabola sort of up here somewhere, like so. So that I didn't draw it very well, but so it just touches in one place on this parabola curve over here somewhere. Okay, so I like to sketch it up because now I know that I should be looking for a negative value for m, and I should be looking for a negative coordinate for the x value at least, and that helps me to kind of, I guess, have a bit of a path for what I'm trying to find out when I solve this question. Okay, so let's get started. So how do we find tangents? Sorry, the point of intersection between a tangent and a curve. Normally we would equate the equations to each other. So x squared minus 4x plus 4 equals mx, like that. And then we would rearrange them and we would solve them. So we'd get x squared minus 4x minus mx plus 4 equals 0. Of course, in this case here, because of this m sitting here, we can't just factorise it and solve it and get concrete numbers at this stage because we don't have the value of m. But we know that if we had the value of m for this to work here, there should only be one solution, so that we only get the one place where it intersects. So what we could do is use the discriminant. So we know that b squared minus 4ac, if we're only after one solution, that's supposed to equal 0. And if we go back up here and look for what our b value is, so we're going to be careful, our b value here is negative 4 minus m. If you imagine taking x out as a common factor, you'd have negative 4, negative m. So that's our b value that gets squared, and then 4 lots of 1, which is a, which is 1, and 4 like that, and that's supposed to equal 0. So you're going to be super careful that you expand this out properly, okay? So be really, really careful. So remember, it's negative 4 minus m times negative 4 minus m. So when I expand that out, I'm going to get 16. I'm going to get negative 4 times negative m, which is it's positive 4m, sorry. I'm going to get two lots of that, so it's going to be plus 8m. And then I'm going to get negative m times negative m, which is m squared. And here, when I expand out this bracket here, I'm going to get negative 16. And that's all going to equal 0. So you can see we get another quadratic, but that's just part of this stuff here. And we just need to rearrange it and solve it. So that's all good. So I'm going to pop that over there. So we get m squared plus 8m equals 0. So m times m plus 8 equals 0. So m equals 0 or negative 8. And we know that it's not 0 because that was this one here, which we don't want. So it must be negative 8. So the gradient there is negative 8. Okay, so now we've found the value of m. So we only want that one there, we don't want that one there. M equals negative 8. We just have to go back now and actually put it back into this equation here, which we couldn't solve before because we didn't know what the value of m was, but now we do. So now we can put it back into there and we can solve it. So let me just move all of this stuff up. Yep. It's hard to find the stuff on it to move it up. It's all a massive mess. Here we go. That's all I want there. Okay. I've made space anyway. So let's put it back in there. So x squared minus 4x minus 8x. So I'm replacing the m with an 8. Oops, now it's a negative 8. So that actually becomes plus 4x. Plus 4 equals 0. So I end up with x squared plus 4x plus 4 equals 0. Oh, like that. So that's going to be x plus 2 when I solve it. Oops. That means I've got a repeated root. It's just one value, so x is minus 2. And that so far makes sense because we already knew that was going to be a negative value for x, and that was going to be a negative gradient, which is negative 8. We've got our x value, which is negative 2, but they want the coordinate, so they want the y value as well. So if we go back to, we can use the line or the curve, either way. The line's probably easier. It's just m times x. So m is negative 8, x is negative 2, so that means here that y is 16. So our point is negative 2, 16. I just want to show you quickly another alternative way of finding the value for m and the coordinates using calculus instead, we've been using this a lot to find things with gradients, so why not give it a go. So we know that our equation is still y equals x squared minus 4x plus 4. And we've still got this tangent here. And what we know about the tangent is that at this point that we're after, which is the point where the tangent and the curve meet, that the gradient at that point for the curve will be the same as the gradient of the line. So how do we normally get the gradient of a curve? Well, normally we would differentiate it. So if we do dy dx, we'd get 2x minus 4. And to get the gradient at that point, we'd substitute in the x value, and that will give us the gradient. So since we know what the gradient is, the gradient has to be m, because that's the gradient of the line. So the gradient of the tangent line has to be the same as the gradient at that point. So what we can do is say that 2x minus 4 equals m. Okay, so what do we do with that? Well, then we go back and we say, well, how do we find where the coordinate is where the curve and the line intersect? Well, we know how to do this. We would equate the equation of the curve with the equation of the line, like that. And then we would solve it. So we get a similar equation to what we had before by just rearranging it into a form that we're familiar with. But what we can do now is that because we've established a second equation with m's and x's in it, we can actually substitute this in for m into that equation there. So we've done some methods like this before, like those optimization questions with like the running track or the cuboid or those kinds of ones where we've had to set up an equation and then find another equation that we can use to replace one of the unknowns. So we could apply the same approach here. So all that happens now is that I'm going to replace that m here with all of this, 2x minus 4 times x plus 4 equals 0. And then what I get, I guess more quickly, is the same quadratic that you get on the previous sort of VI I did, that you can solve and find the value for x and y. So if you went through and explained that all out and rearranged it and grouped it, you'd actually get the same quadratic to solve as we did before. So you'd end up solving that, you'd end up still getting x equals negative 2 and y equals 16. The only difference is that after you've found that, you'd have to go back to this equation here and substitute in your x value to get your value of m.